Hi guys, so these are the work solutions for paper 2 of your mocks. As always, please do not watch this entire video all the way through. I imagine it's going to be quite long, but skip through to the questions that you would like a little bit of extra support with. So question number 1 tells us about Elsie, who is a librarian, and she wants to investigate the length of time that people spend in her library on a particular day. And first of all, it asks us to say whether this variable t, the time, is discrete or continuous. So a variable is discrete if we can count it, whereas it is continuous if we measure it. And time is definitely something we measure, and so I would say it is continuous. She then says that she collects data for 160 people who visited her library on a particular day, and she's written down there the frequency, how many people have visited between some particular times. And the first thing it asks us to do is it has a missing frequency, and it asks us to find that value of k. Well, we know there should be 160 people in total, so if we do 160 minus these values, we can find our value of k. Let's just get to the calculator part of our calculator. And then if we do 160 minus 50 minus 62 minus 14 minus 8, 26. There we go. So that's our value of k. It asks us to write down the modal class. The modal class is the one with the highest frequency. And our highest frequency is there at 62. So the modal class is 20 to 40. And when it says the word class, it means this entire description here. And then asks us to write down the mid-interval for this class. So that is halfway through this class. So if it goes from 20 to 40, our mid-interval is 30. The reason it does that is actually to start us thinking for the next question, because the next question asks us to find an estimate for the mean time that people spend in the library. Now, we can get our calculator to do this, but we can't put these ranges of values into our calculator. So instead, we put the mid-interval for each of these groups into our calculator in the first column, and then these frequencies into the second column. So let's go ahead and do that. So my first column I will call T. My second column I think I will call F for frequency. There we go. And then just bear with me while I write all of that in. So 10, 30, 50, 70, and 90 as our mid-intervals. Oops. And then 50, 62, 26, 14, and 8 as our frequencies. And then to get it to tell us the mean here, we can go to Menu, Statistics, Stat Calculations. And even though there are 2 columns here, this is one variable, statistics, because frequency is not a variable. So my number of lists of data is 1. And then my X list is going to be the T's, the times, and my frequency list is going to be F for frequencies, and then the rest of it I can leave. So I just hit OK, and there we go. We've got our mean there, which it says it's a bit weird in this box. It's got it with an E, so times 10 to the power of 1, which is a bit odd. But when I hover over that, I can actually see the value down here, which is 33.5. There we go. And then looking through the next question, it says is using the table, write down the maximum possible number of people who spent 35 minutes or less in the library on that day. So all of these people have spent fewer than 35 minutes in the library. When we look at this section, we know there are 62 people who spent between 20 and 40 minutes in the library, but we don't know how these 62 people are distributed. So they could have all spent 20 minutes in the library, or they could have all spent 39 minutes in the library. We don't know. But here it says, write down the maximum possible number of people who spent 35 minutes or less in the library. So we don't know where they fall. So if we assume that they all fall less than 35, which they can do in this section, then our maximum number of people would be all of these people and all of these people. So that is 112. Then it says she assumes her data to be representative of future visitors in the library. And it says now find the probability a visitor spends at least 60 minutes in the library. So if we take a look here, these two groups are my groups of people who spend at least 60 minutes in the library, and there are 22 of them. So that 14 plus 8 gives us 22. But if we're working out a probability, we don't just want the frequency there, we want to say 22 out of a total of how many, and we know there are 160 people in total, so it'll be 22 out of 160. You could also work this out as a simplified fraction or a decimal. You don't need to, but let's do it just for completeness. So 22 divided by 160 is, oh, sorry, not 2, but 22. Let me try again. There we go. So that's either 11 over 80, or you could have put it as a decimal. But sorry, it's a really weird way to write the answer. I'm just going to change the settings on this calculator. Let's try it here. Document settings, exponential format, scientific. I think, yeah, that looks like it'll sort it out now. Okay, so if we do 22 divided by 160, there we go, that's the answer I was looking for. So that's 0.1375, but I'd probably avoid writing this as my answer, because actually to round that to 3 significant figures, it would be 0.138, and I don't really like rounding probabilities if we had the fraction there. Right, the question continues actually over onto the next page. I'll just flip this around so we can see it. There we go. And so now we've got a box and whisker plot to represent this information. It asks us to write down the median time spent in the library, and this bar here is our median time, and that is at 26. The interquartile range is our upper quartile minus our lower quartile. Our upper quartile is 50, and our lower quartile is 16, is that right? Yeah. And so if I do 50 minus 16, I get 34 as my interquartile range. It then wants us to show the longest time that a person spent in the library that is not an outlier. Now, just as a reminder, to calculate an outlier, we do 1.5 times the interquartile range, and then we either add that on to the upper quartile or subtract it off the lower quartile. Now, we're looking at a maximum time, so I won't bother doing the lower quartile bit, I'll just do the upper quartile bit. So our upper quartile is 50, and then we want to add on 1.5 times our interquartile range, which is 34. So if I do that into my calculator, 50 plus 1.5 times 34 is equal to 101. And so it would need to be past 101 to be an outlier. And we can see that our maximum value here is at 92. And so there aren't any values higher than this boundary that would be our outlier boundary. So because it says show that, I think I probably need a summarizing sentence there, which just says the max value is 92, which is less than this boundary. Perfect. And then part J, so it says she believes this box and whisker diagram indicates that the times spent in the library are not normally distributed. And it wants us to say something about this box and whisker plot which supports that belief. So I would say the main thing about a normal distribution is that it is symmetrical. So if it's symmetrical, that means that this box plot should be symmetrical as well, and it's not. Now, there's lots of different ways to say that. I had loads of people who were talking about this box being smaller than this box, or this whisker being smaller than this whisker. Those are all reasons, and I gave you the mark for it. But the kind of big reason is the box plot isn't symmetrical. There we go. Right, this one's actually been written on a little bit, but I'm sure it'll be okay. So it says, this diagram shows a park bounded by a fence in the shape of a quadrilateral, and there's a straight path that crosses through the park from B to D. And then it gives us a bunch of measurements, which I think they are all on the diagram. Yeah, that looks about right. And then it asks us to write down the value of the angle BDC. So the angle BDC is this angle in here. And if I take a look, actually this one isn't too bad because I know these two other angles in the triangle. I know that all the angles in a triangle add up to 180 degrees. So if I do 180 minus 41 and minus 120, that tells me what's left there, which is 19 degrees. Then it says, okay, now use the triangle BDC to find the length of BD. So that's this length here. Now, taking a look at this, I think it's going to be a sign rule question because we know one pair across from each other, the 19 and the 40. We know this 120, and we want to find this side length here. So if I use the sign rule, I think I will use it with the sides on the top, but it doesn't really matter. I can say it's 40 over sine 19, because that's one pair, is equal to x over sine 120. And then I can use NSolve to solve that. So menu, algebra, numerical solve. And I've got 40 over sine of 19 is equal to x over sine of 120, comma x. Oh, sorry. And then that tells me that x is equal to, well, 106.4, but I would say that to three significant figures, that is equal to 106. Perfect. Then it asks us to find the size of angle BAD correct to 5 significant figures. So angle BAD is this angle here. There are loads of different ways to work this out, and you're welcome to use all of them. But I think, for me, I'm going to use the cosine rule because I know the length of this side here. I know these two side lengths, and I'm trying to find a remaining angle. So for me, it looks like a cosine rule question. And we've got a couple of different formulas for the cosine rule, but because we're trying to find the angle, I think I'll use the one that looks like this. So cos A is equal to b squared plus c squared minus a squared over 2bc. But you could use the other cosine formula as well, because actually we're going to use NSolve in the end, so it doesn't make a big difference. But anyway, we've got cos A is equal to, and then my side A is going to be this side over here, because it's got to be opposite of angle A, which means my B and my C are these two 85. So 85 squared plus 85 squared minus, and I will actually, as I work this out, I'm going to use the full decimal through, so 106.4, and the rest of it squared, divided by 2 times 85 times 85. So we can then use NSolve to tell us what that is equal to. So menu, algebra, numerical solve, and I've got here cos of x, or cos of A, it doesn't really matter, is equal to 85 squared plus 85 squared minus, and then I'll actually just copy and paste that through, so Control C, Control V squared, divided by 2 times 85 times 85, and I just need to put a comma x on the end. Perfect. So we've got A there is equal to 77.4 5 to 3 significant figures. It then says, okay, from now on, we're actually just going to call it 77 degrees, correct to the nearest degree. So we're going to use that for the rest of this question. Now it wants us to find the area bounded by the path BD and the fences AB and AD. So it wants us to find the area of this triangle here. So for that, just as a reminder, we have two area of triangles formulas, one for when we know the perpendicular height and one for when we don't. And in this case, we don't know the perpendicular height. So we should be using the formula area is equal to a half AB sine C. And in this case, we need the angle that is between these two sides. So considering we've just said that this is 77 degrees, we use this as our angle between these two sides. So then I've got a half times 85 times 85 times sine of 77, which is equal to there we go. So 3,520 to 3 significant figures. Excellent. So the next question then says, a landscaping firm proposes a new design for the park. Fences B, C and CD are to be replaced by a fence in the shape of a circular arc, which is this one here, with a centre of A. So this is like an entire sector here. And they've got a diagram for it. And first of all, it just wants us to say the distance from A to E. Now, just to reiterate, this A is the centre of a circle, and this B through to D is an arc around the edge of a circle, which means any distance from the centre to the edge of the circle is going to equal the radius of this circle. So how do we know the radius of the circle? Well, the radius for the circle here is going to be the same as the radius here and the radius here from the centre to the edge of the circle. So that means the distance from A to E is going to equal 85. Then it wants us to work out the perimeter of the proposed park. So the perimeter is the total length around the edge of this shape. So we know it's going to be 85 plus 85 plus whatever the length of this arc is. And we have a formula in the formula booklet for the length of an arc, which is theta over 360 times 2 pi r. I'll be honest, it might not look exactly like that in the formula booklet because I don't have the formula booklet with me, but it's something pretty similar to that, and whatever you can find in the formula booklet for the length of an arc is totally fine. So in our case, our theta is this angle in here, which is the same as the angle we had before, so it's 77 degrees. So 77 over 360 times 2 times pi times our radius, which is 85. So 77 over 360 times 2 times pi times 85. Oh, there we go, which is equal to 114.232-ish. But remember, we wanted the total perimeter, so that was the length that we just worked out here, but we just need to add on 2 lots of 85 as well for the perimeter. So using the calculator, we have that the perimeter is 208. Oh, why did I write a 3? 284 to 3 significant figures. And then the final part of the question asks us to find the area of the shaded regions of this area here. Now, we've got a few different formulas that can help us. We can work out the area of the entire sector, and we can work out the area of this triangle. In fact, we've already worked out the area of this triangle. So now if I work out the area of this entire sector, I can subtract off the area of this triangle, and I'll be left with this shaded area here. So let's work out the area of the sector first. And again, the formula that I'm writing down here is going to be similar to the one in the formula booklet, but I don't know if it's exactly the same, but they'll mean the same thing. So now if I fill this in, my theta was 77 still. And my radius stays the same. So if I type this into my calculator, 77 over 360 times pi times 85 squared. So that there is my area of the entire sector, 4,854.85. And now I want to subtract off the area of this triangle, which was my answer back here. So 3,520. I'm actually going to just, instead of using that rounded answer, I'm going to find it back up. I'm sure I had it a second ago. Where's it gone? Oh, it's not letting me scroll up anymore. Okay, I will use the rounded answer because I've not got anything better. Fingers crossed. It doesn't make a huge difference. 3,520. So 4,854.85 minus 3,520 is equal to three significant figures, 1330. There we go. So that's my final answer there. Perfect. On to our next question, which is a Voronoi diagrams question, which I always love. And the first question is actually just making sure that you understand what a Voronoi diagram is here. So we've got these 6 restaurant locations are shown together with their Voronoi diagram, and all distances are measured in kilometers. And then we've got Elena who wants to go and eat at the closest restaurant to her. Write down the restaurant she should go to. First of all, if she is at 27. Sorry, I took this as a spare copy of the exam, but somebody else has already written on it, which is totally fine. It's not going to have a big impact. But what's handy is they've already made a mark here for where 27 is. And so 27 is in the region with site B, which means B would definitely be the closest restaurant. That's the meaning of a Voronoi diagram after all. And then it says, what about the point 0, 1? So 0, 1 is here. But it says when restaurant A is closed. So this is an interesting one because really it wants us to adapt the Voronoi diagram a little bit. So if we imagine restaurant A wasn't here, we'd lose these two boundaries because these two boundaries are separating off A and F and A and B. So this edge here would actually extend out, and we can see that as we extend out this edge here, actually this point would then fall within the region with site F instead. And so site F is our closest one when restaurant A is closed. It then tells us that restaurant C is at 7, 8 and restaurant D is at 7, 5. And it asks us to find the equation of the perpendicular bisector CD. Now, there's a couple of things to watch out for here because I saw a lot of people rushing straight into working out a perpendicular bisector, which is really handy for part C. But for this one, just watch out because with this question, when we work out this perpendicular bisector, it's giving you 5 marks for that. Whereas for this one, it's only a measly 2 marks. So they can't possibly be expecting us to actually go through that entire process of working out a perpendicular bisector, which means there must be something else at play here. Now, if you take a look, the coordinates for C and D both have the same x coordinate, which means C and D are exactly on top of each other. So if we take a look at their perpendicular bisector, that's going to be a horizontal line, right? If these ones are vertically on top of each other, the line that splits them in two is going to be horizontal. And any horizontal line has the equation y equals something. So now we just need to work out what does this y equal. Now, we could try and trace it across, but we don't know exactly where it's going to meet there. But we do know that this perpendicular bisector cuts these 2 points in half. So C is at 8, D is at 5, so we're looking for halfway between 8 and 5. You might be able to just think of that, but if you're not sure where exactly halfway between 8 and 5 is, we can do 8 plus 5 divided by 2. Sorry, I just did 8 times 5 instead. 8 plus 5 divided by 2 is equal to... Oh, sorry, that is my fault. There we go, if I do Control Enter on that one. Sorry, guys. I don't know how to use the calculator, really. There we go. So it's equal to 6.5. So that's my perpendicular bisector here, which was a nice easy one because it was a horizontal line. If it's ever a vertical line, it's going to be x equals instead. And now it tells us that restaurant B is at 3, 6, and it asks us to find the equation of the perpendicular bisector between B and C. Now here's one that's worth 5 marks, so this is a full-on, okay, start to finish, can you find me the equation of a perpendicular bisector? It is 100% worth learning the steps for this because those are 5 easy marks if you actually learn all of the steps. So to find the equation of a perpendicular bisector, the first thing we want to do is find the midpoint of B and C. And the midpoint of B and C, we've got the formula x1 plus x2 divided by 2. So my x1 is 3 plus my x2, which is 7 divided by 2. And then the other coordinate is going to be 6 plus 8 divided by 2. The midpoint formula is in the formula booklet, but you'll probably remember it soon enough anyway. So my midpoint is 10 divided by 2, which is 5, and 14 divided by 2, which is 7. The next thing we want to do is we want to find the gradient between B and C. And that is y2 minus y1, so 8 minus 6, divided by x2 minus x1, so 7 minus 3. So that is 2 over 4, which is a half. So that's the gradient between B and C, but we need the perpendicular gradient, and the perpendicular gradient to a half is the negative reciprocal, so it's going to become 2. And that was positive, so this is going to become negative. So right now we know the gradient of this straight line and we know that it goes through this midpoint. So I know it's going to take the form y equals mx plus c. I know my gradient is minus 2, so it's going to be y equals minus 2x plus c. And now I can substitute in one point that I know is on the line, which is this point here, to find out what my c value is. So in this case, my y is 7 minus 2 times 5 plus c. And I can use NSolve to work this out, but I think I'm just going to rearrange this. So this is minus 10, which means c is going to equal 17. And then once I've got all of that, I just need to replace it into the equations. So my end equation of this perpendicular bisector is y equals minus 2x plus 17. There we go. Perfect. And then after that, we've just got part D to finish. Part D says hence, and the word hence always means using the previous part of the question. Find the coordinates of the point which is an equal distance from B, C, and D. So this is an equation of all points which are an equal distance from B and C. Here we had the equation of all of the points which are an equal distance from C and D. And so it is this point here that we're trying to find, that vertex between those two straight lines. So I want to find out when this equation is equal to this equation. Now I've got two options for this. I could go into the graphing part of my calculator and graph this and find their points of intersection. Or I could say, okay, so what I want is for y to equal 6.5, and I could substitute that into this equation. So I'd have 6.5 is equal to minus 2x plus 17. And then I can find out that x is equal to, let's use nsolve. So 6.5 equals minus 2x plus 17. There we go. So it tells me that my x is equal to 5.25 and my y I already know is 6.5. So the coordinate is 5.25. 6.5. But just as a reminder, I could go into the graphing part of my calculator, graph these two equations and find their point of intersection as well. And then it asks us to find the distance of that point from point D. So I've got the coordinates of point D, they're 7, 5. I've got these coordinates here, so I just need to use the distance formula, which is the square root of x1, which is 7, minus x2, which is 5.25 squared, plus 5 minus 6.5 squared. And then I can type that into my calculator. Oh, I missed out my 0.5 there. Perfect, and I can hit enter on that, and it tells me that distance is 2.30 to 3 significant figures. Right, on to the next question. We've now got a probability question. So it gives us some information, and then it asks us to find out the value of each of these, I think as a percentage. So what does it tell us? It tells us that they found that 68% of students have a dog and 36% of students have a cat. So this entire circle here needs to add up to 68. This entire circle here needs to add up to 36. And then 14% of students have both a dog and a cat. So that's this section here. So I can already say that n is equal to 14%. And then looking through my m, where if this entire circle adds up to 68 and this part is 14%, then if I do 68 minus 14, I have 54% as this section here. And then I'm going to do the same thing on the other side. So I know that this entire circle is 36%. So 36 minus 14 will tell me what's left over, which is 22%. And then this section Q, well, that's everyone else who's left over. Well, in total, we've got to have 100%, which means if I do 100 minus these other percentages, it will tell me the percentage that's remaining for Q. So 100 minus 54 minus 14 minus 22. Sorry, I don't know what happened there. I wasn't paying attention properly. Let's head back into this bit here. So minus 54 minus 14 minus 22. There we go. So that leaves us with 10% left for Q. Perfect. Okay, now it says find the percentage of students who have a dog or a cat or both. So that's this section, or this section in total. And in all honesty, if I know this is 10%, then I know that these three have to add up to 90%. And now it says find the probability that a randomly chosen student has a dog but does not have a cat. So this is like, I take that back. So if they have a dog, that's this entire circle, but they do not have a cat, so excluding these people, then that is 54%, or you might have written 0.54. And then this question is subtly different because this one is just asking for this section here. But this one says, what's the probability that they have a dog given that they do not have a cat? So this given that shows me that we're looking here at conditional probability. Now there's a conditional probability formula, but my preferred way to do conditional probability is just to like kind of limit down our sample space. So what I mean by that is we know that they don't have a cat. So here's the people with cats. We know they're not part of what we're talking about. And so I can ignore this section of my Venn diagram. I'm only interested in this part of my Venn diagram now. And now I want to know what's the probability that they have a dog, just including these people. So that's going to be 54%, but now instead of it being out of a total of 100%, it's out of a total of 64% instead. So I could either write that as 54 over 64, or you might prefer to write it as 0.54 over 0.64. It doesn't matter, it's going to give you the same answer, which is 0.844 if we're looking for three significant figures, although you could have also just left it as a fraction like this as well. Right. Our question carries on. So it says, each year one student is randomly chosen to be the school captain of Mirrabooka Primary School. And Tim is using a binomial distribution to make predictions about how many of the next 10 school captains will own a dog. He assumes that the percentages found in the survey will remain constant for future years, and that the events being a school captain and having a dog are independent. So all of this is just setting us up to say, okay, it's fine to use binomial probability. And then it says, okay, now using what he's saying, which is we've got this binomial distribution, we want to find the probability that in the next 10 years, 5 school captains have a dog. So let's set this up properly. We're saying X has a binomial distribution, and normally we give it an N and a P. Our N is our number of trials, and in this case, that N is going to be 10 because we're looking at the next 10 years. And then P is our probability of success in 1 year. So in this case, that is the probability that somebody has a dog. And if we take a look at this, that was 68% of students. So I'm just going to put that as 0.68 in here. So this is our binomial distribution we're dealing with. And then we're looking for the probability that there are exactly 5 school captains with a dog. So now we need to use our calculator to help us with this. We can head to probability, distributions, and scroll down for the binomial distribution. And we have a choice to make whether we want binomial CDF or binomial PDF. Now PDF is the situation we want here because we're just saying we want X to equal 5. CDF is when we've got an inequality that we're dealing with instead. So binomial PDF, my number of trials is 10. My probability of success is 0.68. And my X value is 5. So I'm going to hit enter on that. And it tells me that this probability is 0.123 if I round that to 3 significant figures. The next part of the question says, what is the probability that more than 3 school captains have a dog? So this is the probability X is bigger than 3. Now, in this case, we're going to swap across to binomial CDF because we've got an inequality. Let's scroll down there to binomial CDF. Our number of trials is still 10. Our probability of success is still 0.68. And now here's where we need to be careful because our lower bound is what's the minimum number that we want to have. Now that's not going to be 3 because we want more than 3 school captains to have a dog. So our minimum number is 4. Then our maximum number, our upper bound is what's the maximum number of school captains that can have a dog. Well, there's only 10 in total, so it's going to have to be 10. And now you can hit OK on that. And it tells me that probability is 0.984 to 3 significant figures. The final question, that part 3, is definitely a way more complicated one, because it's saying what's the probability that exactly 3 school captains in succession, so in a row, have a dog. Now we can't use binomial probability for this because binomial probability is only useful for when we're happy with it to be in any order at all. And that's not the case here. We want it to be exactly 9 school captains in a row. So we need to think a little bit differently about this part 3. So if there are 9 school captains in succession that have a dog, I would need it to look like this. I would need it to be a dog owner, a dog owner, a dog owner, 9 times. And then we would need 1 non-dog owner at the end. Or the other option is it's a non-dog owner and then a dog owner, all the way up until we have had 9 dog owners. So these are my 2 options. And so now we just need to work out the probability of this. So we want a dog owner and a dog owner and a dog owner up till 9 times. Now each of these has a probability of 0.68. So it's going to be 0.68 times 0.68 and so on and so forth for 9 times. And then at the end, we can multiply that by the probability that they're not a dog owner, which is 0.32, the remaining probability. But rather than multiplying by 0.68 out 9 times, I'm going to call this 0.68 to the power of 9 multiplied by 0.32. And just as a reminder, there were 2 different ways we could do this. It was either this way round or this way round. So I'm just going to multiply that by 2 as well to work out our total probability. So let me type that into the calculator, 0.68 to the power of 9 multiplied by 0.32 multiplied by 2 is going to give us a final answer there of 0.0199 to 3 significant figures. Perfect. Finally, it says, John randomly chooses 10 students from the survey. State why John should not use the binomial distribution to find the probability that 5 of these students have a dog. Now, this one takes a little bit of thought, but imagine I have 100 people and I'm selecting 10 people from those 100 people. It is true that the first person that I select does have a probability of 0.68 of having a dog. But after I've selected that first person, the next person, their probability will have changed because now there aren't 100 people in that group. There's 99 people in that group. So that's going to affect the probability each time. And the binomial probability and the binomial distribution only works when the probability is the same every single time. So my answer for this, why you shouldn't use the binomial probability, is because the probabilities will not be the same for every single person. Right, let's move on to the next question, which I think, is our final question that we're doing today. So let's take a look. It says, Linda owns a field represented by the shaded region R. The plan view of the field is shown in the following diagram, where both axes represent the distance and are measured in meters. Perfect. And then it tells me about some different line segments, which are some different boundaries. And it tells me that this curved edge here can be represented by this function here. The next thing it asks me to do is just to find f dash of x. Well, that's the differentiated version of this function. So I can do that carefully by following the differentiation rules. So the first thing I'm going to do is I'm going to multiply by my power. So I'm going to multiply by 2. So this is going to become minus 2x. I'll put in the over 50 now before I forget. And the power there is going to reduce by 1. So it was 2, now it'll be 1, but I don't usually bother writing powers of 1. So that's this part differentiated. And then if I differentiate 2x, that becomes just that number 2. And if I differentiate 30, it disappears because it's just a constant term. So my f dash of x is equal to this. If I wanted to, I could simplify it to minus 1 over 25x plus 2, but I don't really need to. Then it says, hence find the coordinates of the point on the field that is furthest north. So we're talking about this point up here, the point that's furthest north. But we've got to be careful here because I know some people just plotted this function and then found the maximum point on this function, which is fine. I gave you a mark for that, but it does say hence. And the word hence always means using the previous part that you just worked out. So it's just asked us to find f dash of x. And f dash of x is the gradient function. So in some way it's forcing us to use the gradient function to find this point instead. So what do I know about the gradient function at this point? Well, I know the gradient function is going to equal 0 because it's a maximum point on my graph. So what I can do is I can solve this function equal to 0 to find that maximum point. So if I go to menu and nsolve, there we go. And then I'm going to put minus 1 over 25x plus 2 equals 0 because I want the gradient function to equal 0. And then just a comma x there. Oops, sorry, I've done something wrong there. I've got my bracket in the wrong place. There we go. So it's telling me there that my x is equal to 50. Now I just need to be careful because it does say hence find the coordinates of that point. So if I know my x is equal to 50, I just need to find my y value now. Now I need to be careful because I don't want to substitute 50 back into this equation because it will just give me it will just give me a value of 0 because that's what we just worked out. Instead, if I want to find the y coordinate, I need to use my original function instead. So I'm going to substitute 50 into this equation. So we're going to find f of 50, not f of 5, f of 50. There we go. So that's minus 50 over, minus 50. Oh my goodness. I just want to put a squared up here. Minus 50 squared over 50 plus 2 times 50 plus 30. There we go, that looks right to me. So I can hit enter on that and it tells me that f of 50 is equal to 80. So that top coordinate there is going to be at 50, 80. Now there's nothing wrong with graphing this and checking that I'm right and checking that I found that maximum point okay, but it's just that when it says the word hence, it wants us to use the previous part of the question, and we have to use that to get full marks. Perfect. Okay, then it says point A has coordinates 0, 0, cool. Point B has the coordinates 0, 30 up here, and point C has coordinates 70, 72. And this one has coordinates 70, 0. So it tells us all of those coordinates. And then it says, write down the integral which can be used to find the area of the shaded region R. So remember, we can find any shaded region between two boundaries and above the x-axis by writing our integral like this. So we want to say where are we starting integrating from? We're starting integrating from 0. We're integrating up to x equals 70. And what are we integrating? We're integrating this function here, our original function. And so that's going to be minus x squared over 50 plus 2x plus 30 dx. Don't forget your notation there. That dx just tells us that we're integrating with respect to x. So this is my answer to B part 1. That's the integral that they're looking for. And then it wants us, okay, then to find the area. Now my calculator can work this out for me. If I go to menu, calculus, numerical integral, I can just type all of this in. So I want to go from 0 to 70 of, what was it? Minus x squared over 50 plus 2x plus 30, and then dx. There we go, and I can enter on that, and it tells me that this is my area under that curve between those two boundaries and above the x-axis. So that is 4,710 to 3 significant figures. Perfect. Unfortunately, that isn't the end of the paper. We've still got one last bit left, and I will be honest, this is quite a tough question. Oh no, sorry. I would say part D is the tough bit, so let's do part C first. So, part C says, Linda used the trapezoidal rule, or the trapezium rule, that's a really American way of saying it, with 10 intervals to estimate the area. This calculation underestimated the area by 11.4, and now it wants us to calculate the percentage error. So the percentage error is usually, the formula we usually see is VE minus VA divided by VA, and then we make it positive and multiply it by 100. That's our formula for finding the percentage error. Now, what they've done is they've told us what VE minus VA is, because that is the difference between our estimated value and our actual value. So they're saying the difference between the estimated value and the actual value is 11.4. So I can just replace this entire section with 11.4. And then I need to divide it by the correct value, or the correct value is the answer I had to my previous question because we integrated it. So we found the exact value, which is 4,710, although I will actually use the full answer from my calculator when I work this out. And then we just need to multiply that by 100. So to work that out, I'll do, what was that, 11.4 divided by, and then I'm going to use the ans button to pull through my previous answer, and then times 100, and that gives me my percentage error, which is 0.242% to 3 significant figures. It then says, suggest how Linda might have been able to reduce this error while still using the trapezium rule, and to increase the accuracy of the trapezium rule if we have more trapeziums, so if we increase the number of intervals that we use, that's a way to increase the accuracy. So I would just say increase number of trapeziums. Nice. Okay. This final question, there's no denying it, is a really tricky question conceptually. So if I'm honest, if you're not aiming for a 7, I would probably save yourself the hassle and not watch through this section, or you can watch it through, but don't worry if you are still a little confused at the end. But if you are someone who's aiming for a 7, then this is the kind of question that at the very least you need to understand after I've explained it. So let me do my best to explain it as well as I can. It says, Linda would like to construct a building on her field. The square foundation of this building will be located such that EH, so the bottom of it, is on this southern boundary. Point F must be touching this curve on the northern boundary. And it says there's a possible location shown in this diagram. And then it says the area of the square foundation will be largest when GH, so that's this edge here, lies on CD. And thank you to whoever was using this as their paper, because I think they've drawn us in a nice little estimation there. So we're saying the best we can do is when the square looks something like this. And first things first, it asks us to find the x coordinate of point E for the largest area of the square foundation of this building. Now, as I mentioned, this was a lot to ask you to do. It is only the final 5 marks of an 80-mark paper, so to be quite honest, as long as you got the rest of this paper correct, even if you didn't get this correct, you certainly could be looking at a 7, but let's go through it anyway. So, we want to maximize the area of this square, and the way we can do that is we can create an equation that represents the area of this square, and then we can find the maximum point of that equation. So if we think about this, the equation for the area of a square is just side length times side length. Now, if I already knew my side length, I'd be done, but I don't. So it's going to be whatever, let's call it EH is, multiplied by whatever EF is. And so I need to now come up with some algebra to describe the length EH and some algebra to describe the length EF. Now for EH, I know that in the end, I want H to be resting here on D. And so E is going to be, remember this part D is at 70. So it's going to be 70 minus whatever the x coordinate of E is, but that's the bit we don't know. We're trying to find the x coordinate for part E. So let's call that x coordinate x, and we know that this length here is 70 minus whatever the x coordinate of E is. But then I now need to find this length here, because I want to be able to maximize this. So I haven't got enough information. If I just say 70 minus x, there we go. If I just say it's 70 minus x times 70 minus x, what we haven't used there is the fact that we are still restricted by the top of this boundary. So then the question is, what is the length from E to F on here? Now, if I'm calling this x, then I'm saying that I want my maximum height, my maximum height from here to here is whatever the function value of x is. So if we've got x along here, this point up here is f of x, it's my function value of x. Now the good news is we know the function value of x. It is this thing here. So I can say that this side length EF is going to be whatever the function value of this is. So that's going to be minus x squared over 50 plus 2x plus 30. Okay, so we just want to find the maximum point of this equation, and we can do that by graphing it and finding the maximum point. So if I go into the graphing part of my calculator, I'm just going to type this in, 70 minus x multiplied by minus, yeah, there we go, x squared over 50 plus 2x plus 30. There we go, and I can hit enter on that. Now at the moment I can't see it, but if I change my view window, let's try zoom to fit. That's looking promising. I'm just gonna head over here and find the maximum point, which I can almost see. So I can click and drag And then I think we can probably see the maximum point there. Let's check. If I go to analyze graph and maximum, let me put my lower bound here and my upper bound here. And it's telling me there that my maximum value is when x is equal to 19.5. Perfect. And let's be honest, that looks about right as well. And now it asks us to find the largest area of the foundation. So if x is at 19.5, that means that this length here is 70 minus 19.5, which is equal to 70 minus 19.5. 50.5, and then I could substitute it all into here, but to be quite honest, that seems like overkill because it's a square, so it's going to be this multiplied by itself. So 50.5 squared is our total area, which is equal to 2,550 to 3 significant figures. Perfect. Thanks very much, guys, and let me know if you have any questions after watching that through.